All right, folks, let's head out. Let's start our afternoon session on the marriage of data and compute, and we'll start here with Larry Rudolph.
Thanks, everyone. And right, no one wants to come late to a wedding, so why don't we start? I don't know which is better. I'll start here. Hi, I'm Larry Rudolph. I'm talking about the marriage or the benefits of sharing and collaboration. It's really the intro talk or the summary talk of this afternoon session. So let me, first, I'm Larry Rudolph. I guess my current title is Distinguished Fellow of the Mass Open Cloud. I've been with Iran since its inception. I've been an academic most of my life, and I'm at 2 Sigma during my day job. And because of that, we're legally responsible to tell you, do not take any investment advice or any money advice from me. Forget about even the legal issues, just in general. Don't trust me with that. On the other hand, when I put on my MOC hat, the answer is I do want you to listen to me. So, it's not going to be about that. But let me just sort of start. In the beginning, there was compute. At least that's, I thought, we just had this whole machine to ourselves, and the machine was really important. There was data for the machine, and then we went on and we got on to HPC and simulated the world and all this stuff. And there was also data, and there were databases where, data was important. And we built up data centers for it, and maybe even you can look at, AWS is really for data. Browsing the web is just providing data, doing commerce and the like. So depending on your point of view, either compute is the king or data is the king. But they've really been in separate camps. And the obvious message is that that's changing. There still is compute world and HPC, and there still is database world. But there's this new thing, which is this combining between the two, which we often call a data pipeline. And the data pipelines come in all shapes and forms, but that's the thing. And there's compute, takes in data, generates data, there's more compute on it, and it's a big pipeline, some of which is shared. The nodes might be database, the data might be in a database, it might be in a CSV file, a data frame file, all those things, but that's what's going on. There's a lot of data pipelines going on all over the place now. In addition, so just imagine this world that, before you can use data, right, you have to download it or make a copy somewhere, make sure you have enough space for it, you have to clean it, normalize it, you have to think about checkpoints and backflows and, all this stuff, and it's a big mess. And really, I tried to sort of define this big mess. We've heard a lot about it this morning, but it's probably messier than I described here. And sort of that's the world that we're sort of kind of in. The world that I want to get to, right, the world that would be nice is you can immediately leverage related works. And it would even be nicer is whenever you did that, you would share the costs in some way. The more times you looked at things. That there should be easy sharing of data. It should be reproducible. If it's reproducible, then you can share data because you don't have to worry, and store it on some immutable storage, so you don't have to worry about sharing because people can't change it. And if it's reproducible, you can still regenerate things. It recovers from failure, it's more efficient. But the really interesting part is the cost of producing may be offset by the cost of from the producer by the cost of the consumer. So it's a different kind of sharing, but you make data and other people use it, you have to worry about the cost there, and you can sort of share those. So it supports a community culture, and the like. So just a quick example, we talked a lot about AI this morning, right? But consider how do you develop these ML pipelines with the AI pipelines, but it's not just for ML. We see this all over the place, and certainly at 2 Sigma, we see this a lot as well. You have to do data collection. So what happens with data collection? You have to download it. You have to perform processing steps. You have to normalize it. There's all this junk that you have to do, And it's all hard, right? It's where do you get the data? Are you allowed to? Do you have permission for it? Are there new versions? Do you have to find code? Do you have to buy the code? Each time new errors are found, do you start from the beginning? And then you do stuff with it, and now you have to worry about the naming problem. So there's a lot going on. We heard a lot of the nightmares before. And that's only the first step. There's a pre-processing step. The same kind of stuff is we're batching stuff, we're getting it. There might be errors. You might have to clean it up. So now we have to go back to the data collection step and do those things over and over. Oh, that came out bad. You have to decide how much you run. If you run many versions of the data, what do you do with that? How do you name it? How do you collect it? Where do you store it? Where do you share it? We can go on and on. Then there's the training part, which is also pretty bad, right? So there's all these steps. You have lots of decisions to worry about. Bugs can happen anywhere. I have to get these GPUs. They can be wasted. I do half the thing, and now I have to sort of change a version. So the costs really add up very, very quickly. So there's the big guys doing AI, and they can have sort of huge costs. And there's the small AI, which you can run on your laptop. This intermediate stage is where really all the costs are. And you get the point, right? It's just more and more and more. All these steps, they're all data pipelines. And if they're sharing, they're now DAGs, directly acyclic graphs, with the nodes and edges, crossing all sorts of domain boundaries. You may be sharing it from someone else. There may be different organizations and different hyperscalers. It's not only that there's human in the loop to make all these decisions, but you don't know who those humans are. Some decisions are made upstream, by the time things get downstream, you don't know what the downstream person, who is downstreaming, who's doing things there. How did you change? What do you do about bad data? Do you get rid of it? Do you turn it to zero? It really matters to the downstream person. Okay, so that's AI. The main point, and I want to say this the main point over and over to sort of build it into your heads, no application is an island, right? It all depends on other code going on. Similarly, no data is an island, right? Data is not just sort of sitting there. It's interacting with other data, there's other code. And similarly, no server is an island, right? It depends on your sort of point of view. So that the data, the pipeline, the hardware at scale, we now have all these weird problems, right? When you go up to scale, there are these emergent properties that come out. And the number and size of data sets, the number of people involved, the number of data scientists, we see that in the data cloud. In the cloud, we figured out how to deal with that scale somewhat, but it's still, we're putting now all these pieces together, all of which scale, all of which weird things can happen that we know about. Part of it is, I think the solution is to share and collaborate, to share information, to share partial results, to share, and to share metadata and sort of collaborate. Here's a picture of black swans, but there's actually lots of black swans. Yet another way of looking at it is this mess, is the fact that a tenant's point of view is they know their DAG. They care about their DAG or their pipeline. And that's the whole thing. And that's what they care about. And somehow you have to get that in the cloud, where the cloud is just a bunch of servers and networks and storage, and that's all you sort of care about. On the other hand, from the provider's point of view, it's exactly the opposite. They care about congestion and packing up the servers and where's the storage going to be and how is things kept cool and how money is made and the like. And what do they get in? They don't get in DAGs. They get in, by and large, of just a bunch of jobs and just a bunch of storage. So there's these two different views, and really we need both things. We need to put two things together, right? The goal is to optimize it just the way we did it for running just the way we did it in the old days. When I had an application and a computer, I put the two things together. The Intel has a whole bunch of probes and counters and analysis to tell you what's going on. which can feed into the application, which can feed back into the, so there's this very close connection. We went to the cloud and we sort of put this barrier between the two. So I just want to stop here for a second to say that I've just described two different marriages. There's a marriage between data and compute, and there's a marriage between the tenant and the provider. And there's actually a marriage between the data and compute. So, you know, it's a four-way marriage. I don't know, whatever we're going to call that anymore. It's a marriage between couples. I don't know. The analogy breaks down. Sorry. So now we can imagine, with all of this going on, just imagine this world where, you know, there's like tons of storage, and any server can access any data, and the probes measure what's going on, and we have multi-level caching, and there's security and usage accounting, and anyone can try out new hardware, and there's no single commercial entity that's controlling everything, and profit is not the motive. Just imagine that world for a minute. Oh, wait, we have that world. We're all here about the MOC, which kind of is that world, right? So so really, you know, if we think about that world, then we can start thinking about doing all these, how these marriages work together, right? So there's sharing data. Well, there's two talks coming on in this session right after me about, about Dataverse and the other data commons. Sorry, that doesn't come out well. They're going to talk about FAIR, the FAIR data principle. I'm sure they do. But it's also, I want to sort of emphasize that data without compute is like a day without sunshine. They're just sitting there doing absolutely nothing. There's no need for everyone to have their own copy if we have this, you know, immutable storage and we have some ability to share with the right protections inside. And I don't know about you, but my days, I'm old enough to know early days that Nokia used to charge you for downloading bytes over their internet. And when you went to a web page and you reloaded the web page, it would charge you for reloading it and downloading the bytes. Really, what's going on behind the scenes is they cached that page, and they just knew how many bytes it was, and every time you went to the page, they would charge you for more bytes, even though they weren't downloading it, until people found that out, right? The web, in the clouds, they're charging for storage. Are they doing deduplication? I don't know, but they're still charging for storage, right? So there's no need for everyone to redo the same data collection, the same pre-processing. We sort of have to figure out how to sort of not keep repeating everything over and over again, or turning on the lights. Okay. Trying to get them on or off? Okay. So there's also, I'm just giving a little quick advertisement, which we're not going into sort of real detail, but at 2 Sigma, we're looking at functional semantic types, which helps sharing data, because I may have almost the same data set as you have, but if I've named it differently than you, how do we even find it? Or I'm looking for some data set, and I don't know. Humans name things in weird ways, and it's not so easy to find it. So we're saying if we can give consistent ways of talking about semantic types of data, and I can exploit those, then I can input the data better and do quality checks and the like. Same thing about sharing this metadata with a hardware state. There should be this talk between the two. We collect provenance. Provenance really helps. I understand what's going on both sides, and it can exploit that. If we can sort of talk, we can learn the attributes of how to do better applications, and we can learn which data code is there. So this is all some sort of shared caching, community caching, all based on the fact that I know what's going on. I know the future. We run these pipelines or these DAGs, and they get run over and over again, so we can sort of learn from that. Okay, we can leverage shared memory. Another little, it's not being covered today, but I really like think about a rack, and there's a board there with tons of disaggregated storage, and any server inside and every machine inside can access that shared data. And if you're really smart, and it's going to be cache coherent, and it can look like real, just uniform non-memory access. Adam showed me a paper from Google which says, oh, we don't need this. In the Google Cloud, there's that CXL and having this shared data in a rack that doesn't help. That's because their workloads are not sharing. At 2 Sigma, we run tons of simulations, and they all start with a similar state. And if you're doing parameter exploration, it all has the same data sitting there. So why make copies everywhere? Why just be able to sort of get something that maps it in and out? Reproducibility is a key concept, and we're going to sort of talk about that. There's the Memento talk is going to sort of cover that. I guess you can't really see this. There's semantic cloud work that's coming out of Red Hat by Uli Depper, and he's not here today, but that's sort of part of that same idea. So during the data pipeline execution, the results of the data transforms may be memoized, and you'll hear that in Memento. In the future, when the same transforms on the same data, the same parameters, in the same environment, there's no need to re-execute. So that's just another way of sharing. The vision is sharing. This is the last slide, because I think I'm out of time. So the place to be is the MOC, a nice phraseology. It's a production level system, and we have lots of data to share. And we have lots of talks today. I guess I missed D4N. That was another one of the talks about the shared cache. So researchers do want to share. They want to share with themselves when you debug and something crashes. They want to share with their colleagues in some way with the right attribution. They want to share with other organizations. So this whole idea of how do you share and collaborate means that we don't have to waste resources re-executing. We don't have to waste resources sort of having things sort of half executed on expensive GPUs and the like. There's a lot of work. We've heard some of that this morning. We're going to hear some of the pieces this afternoon, right after my talk. But there's a lot more work to be done, and I think that's the way of sort of driving down the costs. And the MOC is a good place to play for that. So thank you, and now it's sort of be time for like maybe the engagement party that comes on for the next sort of several talks. But that's sort of where I think we should be going. And I rushed through that. I put my New York accent on to talk fast so that we can leave time for questions.
When you say they want to share, I mean, I think a lot of people don't want to explicitly share. They don't want to know it, but they're willing to have the value of what they did sort of reflect for others, right? You don't actually mean sharing necessarily. Sharing, of course, happens in research, but it's more like they want to get value from what other people did? Is that what you mean by share?
So I think it depends on who you are and what level you are, right? The parameter exploration wastes a lot of code and start from afresh and just change something. And so there's clearly you're sharing with yourself a lot. And you don't want to put that effort in, right? If someone else computed something exactly the same way and you don't know it, you should be able to get it, right? There's just sort of, you don't have to know it. It just should happen. Just the way deduplication happens in data centers. You don't know it's being what's being deduped, right? But in the same way, you can sort of say, well, I'm calling this, and it's available, right?
So I think that's one of the. So this is happening in the public cloud, of course. People are building these shared services where if somebody does something, just like you said with deduplication, other people or they're getting the advantage of it, but they're probably still charging the full rate of the thing. What do we charge? I mean, I know what to charge for things where they're from scratch. We're trying to charge the real cost to users of doing it. Do we just charge the first guy and then make everybody else get it for free, or?
Right. Thank you, yes. That was actually hidden somewhere in the slides, but yes. Right, so the idea is, no. Imagine the world where the consumer doesn't get it for free, right? We start sharing those costs among the users who've done it, right? And not, sure, there's shared services, and we know that, OpenAI says, give me all your data, and we're going to exploit it, and not pay you, not only not pay you nothing, but charge you for using it. That's not the way academics sort of generally work, and we should build this academic infrastructure that doesn't work that way, that says, if I get to use it and I didn't have to pay for it, then I should contribute something, right? If 10 different researchers all access the same data, the person who produced it should, in some sense, have only spent, whatever, P or D over N, and spread that among. Yeah.
I love this, obviously. How do we, who builds it and how do we build it?
Well, the question is, what is it, right?
That's a good place to start, I guess.
Right, and so we're going to hear some talks today, which is some start, but saying we need to start figuring out how do they communicate. The communication is the hard part. How do we get the provider and those probes to talk to the applications? We're starting to get there. But there's a lot of little things that we can do to sort of start getting this there. Having metadata in the right format that everyone can read is another sort of big help, right? Having this like ontologies, so semantic types that it can sort of find stuff and that may symbolically look different, but really underneath it is exactly the same. So these are just the first steps that we do and just keep pushing it more and more.
I guess I see all of those things as necessary, but ultimately it's partly a user interface problem, right? The problem,
I think it's
the problem
more
the data scientist or the domain researcher has is, yeah, connecting all of these things up, but also just a way to manage and deal with all of these data sources.
So one of the talks, Mark's talk, is all about naming, right? Naming is a systems issue from start to finish. So how do you name this stuff? And you'll hear it in talk a little bit of that, and I think that solves a little bit of the problem, which is more than just what you were talking about.
It's one of the 3 hard problems, right?
Right. Any other questions? I don't want to delay the rest of the talks. Great. Well, here's the thank you slide, and thank you.